Hi, and welcome to my talk on Invoke-Build. We're using PowerShell and CI/CD, and I am Joel Bennet, also known as Jekyll. But today I'm not here to talk about any of my side projects. Instead, we're talking about what I spend too much time on at work, which is trying to make those builds just work as often as possible. So, for those of you who don't know me, we'll do a little about me. As I said, I'm Joel Bennet. I'm from upstate New York by way of Guanacaste, Costa Rica. I have been J-Cool online since the 1990s. I'm currently the principal DevOps engineer at Lone Depot. And what else? I'm bilingual. I'm battle faction. I'm blessed. I use he, him pronouns. Let's see. I am this guy on GitHub. I'm also, by the way, and there are links down here. If you go to GitHub/Jekyll, there are links down here to our Discord. How many of you are in our Discord? A few. Okay, so we run a Discord /Slack/IRC. It started in IRC like a long time ago. Before PowerShell went public, we had an IRC channel dedicated to PowerShell. And then as it grew, we've added Slack and Discord, and they're all like bridged together. And we have a giant community, thousands of people that just help each other. It's very friendly, and I highly recommend you come check it out. But you can pick me up anytime I'm on Fosstodon and sometimes on Twitter. I love to talk about PowerShell and DevOps, and so just come find me. Today, however, we're going to talk about CI/CD. So the goal for me is to always use the same workflow, because what we found is if I have one thing that works on my laptop and I have to do it differently on the CI servers, then the chances are that when it breaks on the CI servers, I don't know how to fix it. And I've got developers who can't even be bothered to click the button to find out why, right? Because they don't actually understand how that thing on the CI server works, because it doesn't work the same as their laptop. So I want to write, build scripts that the developers that developers or my teammates, frankly, use on their laptops to build things and have them be the same in CI. So I put here the edge, the cloud, so let's talk a little terminology here. By the way, I forgot I had to scroll here to remind myself. So I'll talk a little bit about containers right at the end if we have time. The industry's starting to get the idea that maybe it would be nice if we could do builds the same way everywhere, and containers is part of the answer to that. But terminology-wise, the edge, when I say the edge for builds, I mean your laptop, your dev workstation, your dev container, whatever it is that you use to write code, I want the build to work there, right? And then I want it to be fast, which on a local laptop usually means lots of caching, because we can't do anything else to make your laptop faster. The cloud is basically, whatever your continuous integration environment is. It's probably a server, might be containers or VMs in, GitHub workflows and Azure pipelines all use ephemeral VMs. But it doesn't really matter what it is. That I'm going to refer to it as the cloud. It's the CI server, right? The thing that makes cloud CI/CD different than my local machine is two things. One, obviously I can make it bigger, right? Because there's only a few of it, and if I need to add CPUs to it to make it go faster or get faster hard drives or whatever, I can do that. But also, generally, it's ephemeral. And what that means is that every time that you go to do a build, you're standing one up from scratch. It doesn't have your source code on it yet. It doesn't have a lot of things on it. It doesn't have a cache of your packages that you need. It might not even have the right build tools installed. So there's a lot of this, like we're always starting from scratch. And the other part, if you guys have used like Azure pipelines, one of the things that we found with Azure pipelines is they are always capturing the log, right? As the build is going, they're capturing the log. When the build is done, you can come and look at the log. But if you come partway through the build, you only get to see what happens after you get here and not what happened before, unless it's discrete in a separate task, right? So we said, well, we want to break these up into chunks so that even if we come in the middle of a 20-minute build, we can see that everything has worked up to the point that we're at. So that's important to us. So obviously you're here in an Invoke-Build talk. Why Invoke-Build? There's lots of tools that you could use for doing builds. There's even a few other PowerShell modules, Saki, and I don't know how to put this. I'm not actually a huge fan of Invoke-Build, but it really works. So Invoke-Build is actually one of the, if not the oldest PowerShell module still in active development, because Invoke-Build was around before there were PowerShell modules. And it still is architected the same way as it used to be before there were PowerShell modules, which means there's a, like, and apologies to Roman if he ever sees this, but don't actually follow, like if you ever look at the source code of Invoke-Build, don't actually do what he does at all. Invoke-Build is a module that you download and install, and when you import it, there are no commands. There's just an alias to a PowerShell script, because actually Invoke-Build is a PowerShell script, not a module. And because of that, it's probably one of the least discoverable PowerShell modules. You can't get help. You have to, like, there are tricks, but you have to read the docs. So if you do use Invoke-Build, read the docs, then follow the directions, because get help isn't going to help you, and get command isn't going to tell you where they are. So, but I mean, these numbers don't lie, right? 1,800 results on GitHub. That's 1,800 build scripts on GitHub that are using Invoke-Build. Over 1 million downloads just from the gallery. And remember, the gallery didn't exist for like 8 years after this thing came out, right? And it's still active, which is more than I can say for any of the other module. Like, I had a module back then when that came out. It is not active. And Saki, for example, has been abandoned twice in the lifetime of this one. So there you go. Why do we use it, even though I just said a whole bunch of nasty things about it? There's a few reasons. The first is it's incremental. It's the only tool that I have in PowerShell that does this concept of incremental steps, meaning it understands that this step has already been completed and I don't need to redo it if I rerun it. And it also has this like checkpoint things. It supports chaining via dependencies, so you can say if a user wants to run the publish command, well, obviously they have to run the build command first, and before that they have to run the download dependencies command, and so on. So obviously, I remember saying to Roman at the beginning of this, why are you writing a task framework? PowerShell is a task framework. And he said, yeah, but I can't express the dependencies in PowerShell. I can't say this one depends on that one, but I don't mean always run that one at the front of this one, right? Because I don't want to rerun it over and over. And then there's a lot of stuff about checkpoints and that whole file system thing. Invoke-Build understands the concept of inputs and outputs on the file system. So if there's source files and there's a DLL and I don't want to rebuild if the DLL is newer than the source, then we can skip it, right? I'll get into all that a little bit. This is the point where I go, sorry, yes. You all know the kids' book, right? This is obviously a play on children's books, but I actually put it there because this is the core truth, right? As developers, our work pattern is code, run, code, run, code, run, code, run, code, run. The sooner I can see the result of running my code, the sooner I can start to iterate, and the faster that I can get it right. I never get it right the first time, so I always need to build, run, build, run. So let's look at some invoke code, and maybe we'll come back to slides, but I'm not promising anything. Let's see. Actually, here. I'm going to abandon slides. Then we know we won't come back. There are more slides. What's my time? I just realized that I had a timer on the slide deck and I just killed it. Oh well. All right. Can everybody see that? And is there anything I can do to get this row of lights off? No? Nobody knows. All right. Can everybody see that? Is anybody like completely unable to read that? It won't all be pink, I promise. All right, so let's look at build scripts. This is the first, this is like your, like hello world of build scripts for Invoke-Build. All Invoke-Build files have or all projects that use Invoke-Build have to have a script that's named something.build.ps1. And that's how it finds the build script, right? You can actually name it .build.ps1 without anything on the front. But given that we're now cross-platform, probably don't start your file names with dots. They disappear on Linux, in case you didn't know that. So we're gonna have a file. It's gonna be called something build.ps1. It's gonna have a default task. So the rule in Invoke-Build is tasks are basically just functions. Instead of saying function, you say task. You write a name, you write a script block. There's a more complicated syntax, which I'll show you in a minute. But the key is the default task is whichever one comes first. So at the top of my file, I say task, and I introduce this default task. And I'm defining this one in terms of other tasks that don't exist yet, but that doesn't matter. So there's some kind of convention, and I'm going to do it on this file because it's the hello world of Invoke-Build. There's some kind of convention in the community to use dot as your default task. I hate it. You'll see in a second. I'll run this, and you'll see what I mean. But that thing means the default task is dot, and the default means run, restore, and then run build. So I have a task restore, which does exec.net restore, and I have a task build, which does exec.net build, right? I also have a task clean, which you notice that's not in the default, so it's not going to get run by default. Now, there's a couple things I want to point out just in this. If you haven't seen Invoke-Build at all, task is actually an alias. And you see how it's like, I don't know if you can tell, but it's actually underlined two different ways in my VS Code because PS Script Analyzer is angry because task is an alias, which is funny because PS Script Analyzer can't see the command that task is an alias of. So I did a little digging. It turns out I have got a VMware commandlet on my box called getTask. That's actually an alias for getTask. By the way, does not work because getTask has nothing to do with any of the rest of this. But if you actually run, I don't know if you know that, PowerShell does implicit aliasing. So if you have a command with the verb get on the front, you can just you can type just the noun and it'll run it. And that's what that is. VMware didn't alias their getTask. And then the other thing is this exec down at the bottom. Exec is another alias from the Invoke-Build. And what it does is it basically runs a native command, and if that native command doesn't have a 0 return, it turns it into an error. Now, they're adding that to PowerShell finally in the next release. But this has been in here since 2012, okay? So, so we basically, whenever we do a native executable, we wrap it in exec so that it turns into an error if it errors. And then the last thing is this remove is also another feature of Invoke-Build. And what it does is it removes folders with recurse, and it doesn't crash if the folder doesn't exist. So remove bin obj will delete the bin and the obj folder and everything inside of them if they're there, and if they're not there, it will do nothing. So let's just see that run. This is not, oops, I've started toot. This is probably not big enough. All right, that's too big because we've made my prompt smack into each other. All right, so I am let's say, weather. So I have in the, and if you've opened up the repo already, I copied some demo apps from like .NET, the .NET sample website. And it's like 3 or 4 container apps that I'm playing with for this demo. The weather API is just a little DLL that basically you call it and it returns fake weather because it's not actually doing anything. But it's a .NET app. If I, get child atom, you can see there's a bin folder and an obj and, source code and stuff. There's also the CS_proj, which is the important bit, right? So I have no Invoke-Build script here yet. So, oh man, I need my, all right. So we're gonna just copy this 0.1 build that we were just talking about down there. Whoops. Right? All right. So now, ta-da, it's there. All right. So now what we're going to do is we're going to try to just run it because we're new to the team and there's a build script. So we're just going to run that. And of course, I got a whole bunch of stuff about VMware's customer experience program. So, lesson number 1, if you use Invoke-Build, please don't get rid of your build.ps1 like with no decorations on it that's going to call Invoke-Build to call this, because otherwise you're going to have people doing what I just did, and this is what's going to happen. Lots of red, don't know what's going on. All right, so the better way to run it is to run Invoke-Build, which you can see even in my history autocomplete, I always hold the shift down a second too long. So when we run Invoke-Build, it's just going to do what the Invoke-Build says, restore and build. Now I mentioned there's a clean task in there. If you want to run a specific task, you can always do that with Invoke-Build. So you can run task, and you can say clean, and it does a clean. So now if we do a ls, you see the bin and the obj folders are gone. Yay! All right. So enough on that. Going to 2. So the next step, essentially, from my point of view, the first thing you should do after you know how to write an Invoke-Build script is stop using those aliases. Because first of all, the little yellow squigglies are going to drive me crazy. But secondly, it's a generally accepted practice in our community that you don't use aliases in scripts that you're going to keep around. So, hey, look, I added documentation comments. So the first thing we're doing is just we're just going to clean it up. We're going to get rid of the aliases. And I'm going to make it so that people can run it directly and I don't need a separate build PS1. So to do that, and I'm going to close this. To do that, I really feel like you can't see that. Can you guys see what it says after my invocation on line 17? All right, the front half of the room can see. All right, y'all in the back, I'm sorry. I don't know. I can't hear you, so. So there's 2 things. One, actually, is I have a parameter here I wanted to just point out. In Invoke-Build, if you have your .build.ps1, any parameter that's on there is automatically available to all of your tasks as a script scope variable, okay? So what Invoke-Build does is it pulls your tasks and your build script and basically dot sources them all into one scope. So any variable that you define in the script scope is available to everybody. It's kind of like if you were in a module. And that, by the way, for those of you, remember I said don't do this? The reason why Invoke-Build is still a script and not a module is that way when you run it each time, it gets a fresh scope. Because if it was a module, when you import it, it's got script scope. And when you run something and it sets a script scope variable, that variable sticks around forever. This way, it gets flushed just by the fact that the script ends. So that's why they do that. So the first step here is, if my invocation name is not Invoke-Build, then check if there is, in fact, a command named Invoke-Build on this laptop. And if there is not, install the module and import the module. And then Invoke-Build and pass it my invocation, my command.path, right? So all of that basically to say, hey, on a new developer's laptop, if they just run this script, it's going to work. If they didn't have Invoke-Build installed, it's going to install it. And if they are upset about that, they should have read the file before they ran it. And then it's going to return at the end because obviously when Invoke-Build runs, it's going to run the rest of this, right? So we've got the same things, exactly the same things as before, but I've resolved all the aliases out. And you'll notice that I've moved the add build task down to the bottom here, even though I've defined these up top. So let's see what happens. Well, let's see what happens. We have to copy files. And I've accidentally moved this instead of copying it earlier. I'm going to try not to do the same thing this time. Huzzah. All right. By the way, I'm not trying to recommend people do this, but if you see me swapping back and forth, I always run everything in the terminal. I never run anything in the VS Code terminal, except when I'm using a live share and doing it like in VS Code and the other people can see my terminal, but they can't see this. That's just old habits. It's not a best practice or anything. It's just, back in the day we didn't have that thing. And so I'm going to run O2 build, and we'll see basically the same thing as we saw before, right? Nothing really better. The difference is that this time I can actually run O2 build, and I don't have to run Invoke-Build because O2 build runs it for me. So that's obviously a little bit friendlier for your, well, everybody that's not on your team already when you make this change. The thing that I'll say is, and I'll talk, well, maybe, yeah, we'll get that. We'll come back to this idea of bootstrapping. So that's the second step. So let's move on. Let's talk about how can we do things better. One of the things that we talked about in the reasons why we're using this tool in the first place is the incremental build support. So I want to show you that. I've done two things here. First is I've added this clean switch. And I'll show you what that's for in a sec. And then the second thing is I've added incremental builds. So we'll go through here, right? Same stuff as before. At the top, I've got this check. If clean, add build task. Now I'm still using that default build task, but in this case, if you passed the clean switch, I'm adding the clean task on the front. So that means that now you don't have to do what we were doing before, where you do Invoke-Build -task clean, and then Invoke-Build to build, right? Because you don't know what the actual order of the tasks are that need to run probably. So now you just pass -clean, and it changes the order, right? And you can, hopefully you can all see that you can do this with any number of different switches and any number of different order. Like if you wanted, for example, to add a switch that says test, and you have a test step on the end, and it doesn't run by default, but it does run if you add the -test, you can do that. So this is how you basically change what the default is with a switch. And then this is what a incremental build step looks like. So the idea is you have an inputs, you have an outputs, and then you have jobs. So this is the advanced syntax I mentioned earlier for add build task. So it's still the same basic shape, right? Add build task, a name, and a script block. But the script block went down inside here under jobs, and the second parameter is basically this hash table. So there's a couple things to know about this. One is, remember up here, I've always been calling add build task with a name and then 3 other names. So add build task inherently supports arrays. And you can do arrays like this, or you can do them down here in the jobs. You can put an array of script blocks. You can put the name of one of the other jobs and then a script block, or a script block and then the name of one of the other jobs. Any mix, match, however you want. So there's a lot of flexibility there in terms of saying, well, this step is like a meta step that calls all these other steps. We think of it as a dependency. So it's a little bit like saying, I depend on, right? The result, if you put 2 names in, if, let's say that my restore and my build, I wanted to always clean. So I can go in here in restore, I could put clean here, clean comma. Whoops, I'd have to not typo it. And that would mean every time we run restore, we're first gonna clean. Don't do that, but you could. And if you did the same thing on build, the important thing to know is that it's not gonna clean twice, right? So if you run the default build, it's gonna see clean on the restore, so it's gonna go clean and then restore. When it gets to the build, it's gonna say, I already ran clean, and it's just gonna run the build. So, how do these inputs and outputs work? The input is gonna do get child item. Now this is, bear with me for a second, this is the restore step, right? So what we're calling here is basically NuGet restore. It's gonna download packages. So the only thing that can change which packages we're gonna download is the CS proj, because in the CS proj is where all those packages are listed. If you aren't familiar with .NET projects, I'll show you. The weather API you see here, this package reference, right? So it's got a reference to Swashbuckle, and that's a NuGet package that it has to download. So if the CS proj file has changed, then maybe I need to download new packages. When you run NuGet restore, it writes a project.assets.json file to the object output location. Basically, code gens this JSON file with the full list, because the CS proj file can have like wildcards or version ranges, and the project.assets has a hard-coded, this is what we're gonna use. So NuGet restore writes that. So I'm using that in my inputs and outputs. If the CS proj file is newer than the project assets JSON, we're gonna run this step. If the project assets JSON is newer, we're not gonna run this step. Does that make sense? And it's basically like oldest and newest. So if there were like 14 files in one and 5 files in the other, the newest file on each one is what counts, right? So if the newest file in the inputs is newer than the oldest file in the outputs, then we're gonna run the step. All right, and then for build, it gets a little bit more complicated, because now we're looking at all the source files, and in .NET Core, they changed things. This line, this used to be simple, get child recurse star.cs. Now I've got this where full name not match thing in here. Basically, in .NET Core, they generate your assembly info CS file. I don't know, let's not get too into detail here, but the bottom line is there's a C# file that gets generated by the build into the object folder, like the intermediate output folder, right? And that file is new every time you run the build. So that means that it's always newer than the output. So we're basically just excluding that in our get child item. And then in the outputs, we're looking specifically for the DLL that we care about, because we don't want to get fooled by the dates on some dependencies or something else like that that got copied in there. And then that's it, right? I will also point out that I am hard coding the output location for .NET. We do that in all of our build scripts. We usually make it a parameter you can pass in. I'm not doing that here yet, but it's generally the case that in your build environment, you'll want to send it somewhere special. meaning out on the CI/CD, you'll want to send it somewhere special. So we usually have that hard-coded. And then same clean. Okay, so we're going to do the same thing we did before, just kind of prove that we're not just hand-waving. No, I don't want to install C#. All right, so we're going to Invoke-Build. And this time, I'm just going to use that -clean. Now, I just, as I was typing that, I remembered I wanted to tell you why I'm doing this. So that -clean is not a parameter on Invoke-Build, right? If I hit Control Space, no completion. If I do task, right, I get completion. There's a whole list of parameters here, right? But clean is not among them. But if I pass clean, Invoke-Build will take that parameter that it doesn't know anything about, and it'll pass it to the build script. So this gives me a shortcut. I don't have to know the name of the build script in order to pass it the clean switch. I lied. What happened? You're right. Thank you. That was way faster than I would have been. All right. There you go. So, yeah, by the way, if you see that error, I hadn't read it. I hadn't finished reading it. Can't bind positional parameters. No names were given. The name it was talking about is the name of the build script because we had 2 in the folder. So this ran clean, right? You see task clean done. Then it ran restore. See the missing output here? Missing output basically means inputs and outputs. The output didn't exist at all, so we have to rerun the step. So if I run this again, you'll see, oop, what happened? Oh, I did clean. Haha. If I run this again without running clean, you'll see skipping up to date output, and it's basically instant. You can see in my little timer down on the left, or your right, 69 milliseconds to run the whole build, right? Because nothing actually got done. If we were to go in and let's just make a change to something. Oops. We're just gonna. So you'll see out of date output, right? Here. And I apologize, the gray is gray, and I can't do anything about it. I mean, I could technically change my color scheme for the gray to be brighter, but basically just says that DLL is out of date, and it reruns the build. And it's based just on the CS. Now, I encourage you that if you start doing this on projects that you don't own, that you make really, really sure that the people who do own the project understand what the conditions of the inputs and the outputs are on these steps. Because you understand that sometimes there's like, and in my case, I'm only looking at the C# files, because I know that's what's in here. But maybe there's a JSON file in here that when I change it, I need to rebuild, right? So in that case, I need to change my condition here to make sure that I pick up changes to the JSON file as well. So this isn't automatic. Obviously, to some extent, .NET and other build tools can handle this for you, and you can just let them run, and they're not going to do more work than they need to do. But the reason I'm harping on the input-output concept is not every tool that you're using does that, right? So a whole lot of tools are going to redo the whole step just because that's how they work. They don't do checking and not building. So you can add that to anything, but you just have to make sure that, you know, that the check that you're running is valid. And I will say, I always feel like it's pretty safe as long as it always fails on the CI server where everything is clean, right? And I don't ever skip building on the CI server where there's no output. If it skips a step on my local box, then the test is if I do -clean, will it run it, right? So if I do -clean and then it works, then we're good. Because at the worst case, if I got it wrong, you have a workaround. All right. What else? I don't think I had anything else I needed to right? That was everything we talked about in there. Yes. Okay, so I think the next step is basically what we have done is once we had these working, we copied them. We copied that script with the steps in it into another project and reused it and tweaked it a little bit. And then we copied it in another step, and then 2 months later we found, oh, we really should have put a dash recurse on that get child item. So we put it in, and then a week later somebody else found the same problem in their copy of our thing, right? So what we did is we moved all of our task definitions out of the build.ps1 into separate files, which Invoke-Build has a convention for doing that with calling them .tasks.ps1. And we moved them all into a shared repository. So we have a repo called Invoke-Build tasks, because we're really clever. And we put all of our shared build tasks. So the idea is, if you have something really unique that you need to do, you can just put it in a tasks folder in your project. And if anybody ever copies it, they're not allowed to copy it into their project. They have to copy it into the shared repo, right? So you'll see here, this is my trick for that. What we do is we say you can have a tasks folder in your project, or you can have the tasks up one, right? So in ours, we actually don't call it tasks, we call it Invoke-Build tasks, as I mentioned. We expect developers to have the Invoke-Build tasks repo checked out in the same folder as all their other repos. So the idea is that, there's that shared tasks is up one, and I actually have a thing in our, well, I'll show you this in a sec. See this bootstrap here? This is the bootstrap step that we did before. So the thing that installs Invoke-Build if it's not there, I've put it into the shared repo because I don't want to have the same exact step in everything. I've done the test here, and the reason is because if I call this, then my invocation script name thing gets complicated, and you have to do all this get my call stack nonsense. And I couldn't be bothered, especially for this demo, because it's so complicated when you look at it. But basically, it just does, call the shared bootstrap script. And then at the end, well, we still have this here, but you notice now we've got a whole bunch of .NET Restore, .NET Build, .NET Test. I added a test step, and I added a publish step. So at the bottom, we're going to basically do .source this initialize. And what we do is in our shared repo, and I'm going to show you, we'll talk about it. I'll go into this a little bit more in a minute, but this is the, you can't see that. Here, I'll open initialize. So this is the initialize script. It basically sets a bunch of variables that I find useful to be, essentially, there are things I have to otherwise calculate over and over, right? So for example, Invoke-Build gives you a default variable called build root, which is the folder that the .build.ps1 file was in. But there are other things you might want to standardize, like where does the output go? We were talking about that earlier. And here's one that's super useful. So I calculate the build system based on whether an environment variable exists or not, right? So if there's a variable called GitHub Actions, then my build system is GitHub Actions. And if there's a variable called Team Foundation Collection URI, I'm in Azure DevOps, not Team Foundation. I don't know. Otherwise, I'm in none. Now, these are not the names I would have chosen for those build systems, but it turns out that Pester has a switch for build system that expects one of those three values. And the reason is because they customize their output so that GitHub and Azure will recognize things as test failures. So we have this variable. We set it for the purpose of Pester. When we're going to call Pester, we're going to pass that variable in. But then we use it for other stuff. Like here's a little extra build environment magic. If the build system is Azure DevOps, set build header. Now, set build header is a feature of Invoke-Build that you've been seeing this whole time, but you just didn't even know. See where it says task restore, done restore, task build, done build, right? So that's the build header and the build footer. You can basically create a little template. What I've done here is I've customized the template to add pound group. Pound group and pound end group are what Azure DevOps calls logging commands. And they're magic. If you put these in the output, then you can fold it in the Azure DevOps output thingy, which is really nice if you're running an Invoke-Build with like a whole bunch of steps together. You can at least collapse them and see what's going on. Obviously, I only want to do that in Azure DevOps because anywhere else it's going to say pound group on the front of my output, which is really weird. Anyway, there's a whole bunch of other stuff I'm not going to get into. We calculate temp directories, like see this. This is the temp directory that GitHub uses. This is the temp directory that Azure uses. And there's a lot of that down through here. There's a thing to calculate the SHA based on what the build environment knows. And if we still haven't figured it out, try calling getrefparse because that'll probably work, etc. So these are variables that we use in our builds. And at the bottom here, there's a section. You see it says if .NET tasks. And it sets some extra variables that I want for my build. So it makes sure that there's always a configuration variable that's either release or whatever you passed in. And then .NET projects, and it says basically look for start.proj, and we're going to return the folders of those as the project folders. And then in our tasks, we can take advantage of the fact that those were already calculated. So now our .NET publish task can actually support building a whole array of projects, right? And it has an if at the top. Now this is the other piece. So we talked about inputs and outputs, right? There's also if, and you can combine them together. So in this case, if is if they set .NET projects. If .NET projects is not set, we're just going to skip this altogether. If it is set, then we're going to call getChildItem, and we're going to look for star.cs. And if it's newer, then outputs. And again, we're going to use that .NET projects to figure out what the name of the output should be, right? Because the name of the output should be the name of the project.dll. And then we've got a build, and it does a for loop on them. I forgot about this. I have some stuff in here to set Git version. So we use Git version a little bit religiously, or else it wouldn't be in the demo. I just don't even think about it and pasted it in. Git version is a tool that calculates a semantic version number based on your Git history. And you can tag your repository to force a specific version number. So if you tag a commit in main, when you build it, it will come out that number. But then the next commit in main will auto increment, from that. And if you're in a branch that's not main, it'll come up with a pre-release. And if you're in main, it doesn't have a pre-release, and so on. So we use that for everything. So there's some stuff in here to make sure that if the Git version variable is set, then we set an option. So this is something that gets overlooked a lot, but .NET, hopefully you all know, DLLs can have version numbers in them. So to get a version number in the build, all you have to do is build it. But the version number won't make any sense. So if you want it to make sense, then you have to set it. So this basically sets it using the P option and sets version to the Git version informational version, which, by the way, the informational version and Git version, here, watch this. I'm on a sidetrack. I apologize. I'll come back in a minute. No, I'll come back in like 10 seconds. There. Oop. Oh, yeah, .NET Git version. So this is the output of .NET Git version. It's a JSON file. See the informational version line here? So this is based on a config file that I have, but you see it's basically the version number. +7 means we're 7 commits deep in this branch. The branch is main, and the SHA is the SHA of the commit that we're building, right? You can tweak that. You can tweak what goes in the informational version to your heart's content. At work, that would have had the date in it and something else. Doesn't matter. But we pass that into .NET. It uses the first part as the version number of the DLL, and it puts the rest of it in the information version. So when you open the DLL and you click on the details tab, you can actually see all of that, which means that any given DLL, you can open it up and see which commit from what repo it came. All right, so I'm going to skip running that one and just go to the next one, which is just a little bit more. So this is basically like we're done here. Check this out. What we did here is we added all these parameters. And remember I told you these are all script variables. So any parameter you want, and this is what we do. Now I can call this Invoke-Build, and I can say, which project do I want to build, right? So this build file goes, if you saw my source folder here, we've got like a folder for container app weather API, container app tests, container app to do, whatever. So these are the 4 apps, and then one of them is a test project, and we only run tests on things that are test projects, right? And we added a whole bunch of options, so you can specify any custom .NET options you want. This is basically like little hash tables, stuff anything in there that you need to. When we build in containers, we usually hard code the runtime so that it comes out. We use, UCR, which is use current runtime, and that way it comes out as the runtime of the container. But if you're running on a VM and you want to build a different OS, you can do that with .NET. So that's that. I had another slide I was going to show you. I think I'm out of time, right? Yes? Yes. So I'm going to go this way. Why is it not going this way? There we go. Write this URL down really quick and check it out. If I if things had been 3 months later and I had filed my talks for this conference 3 months later than I actually did, we would have had this session about Earthly instead of about Invoke-Build. We're still using Invoke-Build, but I desperately want to get us onto Earthly. It's really cool, and the thing is basically it's a CI built on BuildKit, which is the new engine for Docker build, right? And what it does is every step of your build runs inside Docker containers, but it still produces local output in your folder. And what that means is you can run the build exactly the same in CI and on your laptop because it's in the same exact container. It's really neat. We haven't switched to it. Like I said, I'm still learning this thing. But everything is cached because Docker is cached, right? So if your inputs are the same as the last time, then we just use that layer from the last time. So it's very interesting. Let's just leave it at that. Thank you very much. That's the URL for the presentation if you want to dig in more, because obviously I skipped a whole bunch of slides there at the end. Thank you.